Hey everyone, this is a quick tutorial for the acid cutouts lab activity. That is very similar to the ionic one because everything is made up of ions, obviously. So we are going to illustrate that acidic compounds must combine in ratios that are also neutral where there are no charges. You will be using draggable ion cutouts to represent the ions with the different charges in Google Slides. And don't forget, you have some resources available to you. The printable common ion sheet, which you should have by now. We are going to be using our H plus hydrogen ion for our acidic hydrogen, and then we are going to bond them to either a set 4, set 5, or set 6 anion. So these are going to be your monatomic anions, and here are your polyatomic ions with a 1 minus and 2 and 3 minus charge. So this is going to be very handy for us. There is also on here that printable periodic chart of ions, which you can use over here for your anions. Or just like before, you also have your periodic table. I told you how to label it with your 4 minus, 3 minus, 2 minus, and 1 minus for your different columns. So any of those will be useful, but my guess is it's going to be these, especially when we get into the polyatomic ion names. So what you'll be doing is you'll be trying to write the acid for the ion that it contains. All right, so that, like in this example, an acid containing sulfate. There are two types of acids. There are hydroacids, which is hydrogen bonded to a monatomic anion. That would be something in set 4 here. Or there is an oxyacid, which is a hydrogen bonded to a polyatomic ion, which would be in set 5 or set 6. This is where knowing those ions is super important. If it's a hydroacid, you name the acid hydro, the element, then you change the ending to say ic, acid. And if it's a polyatomic ion, if it ends in ate, it becomes ic acid. If it ends in ite, it becomes us acid. So I always think of my favorite dessert. I took a bite of my favorite dessert. It was delicious. I ate the whole dessert and ugh, I felt sick. All right, so for example, if you have something with the sulfate ion, hydrogen is always going to be the H plus, the cation involved, and sulfate is SO42 minus. So SO42 minus is a polyatomic ion ending in ate, so it becomes sulfuric acid, and you can crisscross to get your correct charge of the correct formula to cancel out the charge of the sulfate. You need two H pluses to cancel out that 2 minus charge. All right, so that is what we are going to use. Use your notes or the periodic table to figure out if it's a hydro or oxy acid from that previous slide. You want to make that perfect rectangle and use your subscripts, okay? Use your subscripts. You should know how to do that. So, like I said, these are draggable, all right? An acid, for this first example, that contains the chloride ion. It ends in IDE. So that means it's over here. Chloride is a 1 minus, or you could look over here, chlorine is a 1 minus. So either one of those two things could tell you. Since it's just an element, it's going to be a hydroacid. So you can make sure that you click on it, and then you can see how you have those little crosshairs up and over. You are going to drag that over here for the type of acid it is. The formula for chloride is Cl minus. You can write Cl minus or Cl1 minus. It's hydrochloric acid. You have an H plus and a 1 minus to cancel it out, and you have your HCl. Okay, for your second one here, the acid containing sulfate. Sulfate is SO4 2 minus. It's not on your periodic table. It's one of those special ones we needed to know. SO4 2 minus is an oxyacid. That is an acid that contains a polyatomic ion. And I ate the whole chocolate cake dessert, so I got sick. So this is sulfuric acid, H2SO4. And I dragged my H's and I dragged my S2 minus over here so that I make my nice perfect rectangle. All right, so let's take a look. An acid containing fluoride. IDE means it's just an element. So I can either come here to find fluoride as F minus, or I can go to the periodic table and I see that F is in that 1 minus range right here. And I write and click in here F, and then I choose, oops, it's already on superscript. F, and then superscript is going to format text superscript or selecting control period. So I can write minus or control period, or you can write F control period 1 minus. I don't care which one you use. Since it is just an monatomic, one atom ion. It is a hydroacid. Wait for this to have the little crosshairs over there with a little arrow cross. And then you can click on this actual thing right here. And if it's a hydroacid, it is hydrofluoric acid. All right, so I have an H plus. Fluorine is a 1 minus. So I would come over here to one of these, make sure that you have the little arrowheads coming up, and you can see that that H plus and that F minus cancel each other out. So my formula is capital H, whoops, capital H, capital F, HF, just like that. All right, so that is how you would do that one. I'm going to scroll down here to an acid containing a nitrate. All right, so nitrate for number 4 on here, nitrate is NO3 1 minus. So I would write, click in here, NO3, and then I would do superscript 1 minus or just minus. This is a polyatomic ion, so it's an oxyacid, and it ends in ate, ATE. So I ate the whole thing, I got sick. So this is nitric acid. So I would come over here. NO3 is a 1 minus charge. I would show it put together, and I would click in here and write HNO. Whoops. HNO3 as my formula for that. If I had a nitrite, yeah, I would use a different name. If I had a nitride, I would use a different name. If I had something a little more complex, like an acid containing oxalate. Oxalate is over here in set 6, C2O42 minus, oxalate. So I would click in here, C, oops, C, capital C, 2O4, 2 minus. So notice that we have some subscripts and some superscripts. You can always come in here where it says text. Well, I have to click in the box. Text and super or subscript, or learn that control period, control comma for Google Slides and Word and Doc. It is an oxyacid, so I'm going to move that over here. Oxalate means it is oxalic acid. which is what is going to give chocolate that tartness. And let's see, it's C2O4 2 minus, so it's a 2 minus charge. How many H's am I going to need to combat that 2 minusness? I'm going to need another H. So I'm going to drag that over. Whoops. See, if it doesn't work, you can always hit Control Z. You want to make sure that the blue boxes aren't up like that, and then you can drag the whole thing on over. Control Z just undoes anything. But now we get that nice little perfect square there. So if I have two of my H pluses, it's that same crisscross method we have been doing before. I'm going to need two H2s and one oxalate. H2C2O4 is going to be my oxalic acid. So I am going to click in the box again, and I am going to write H2C2O4. And that is my formula for that. Don't forget, when you are done, come down because yay, you have completed. Don't forget to turn it in on Google Classroom. All right, let me know if you have any questions. Good luck.